Okay, in this video, we're going to be looking at section 2.5, problem number 40. And in problem number 40, we're asked to sketch the graph of one continuous function f that has all of the indicated properties. All right, so there's a lot going on here, and let's try to break this up piece by piece. So the first two lines, or the first bullet, has to do with the first derivative, gives us information about the first derivative of the function. The second two lines gives us some information about the second derivative of the function. And then this third bullet tells us actually about end behavior. So that's looking at large values of x in the negative direction and in the positive direction. And unfortunately, this picture here is really hard to tell what's going on, but this is saying as x approaches negative infinity, f of x uh, equals 2. And then this is saying as x approaches positive infinity. So the limit as x approaches negative infinity is f of x equaling 2. So that's like saying as x approaches negative infinity, the output is approaching 2. And as x is approaching positive infinity, the output is approaching 3. So let's go ahead and start to figure out how we're going to graph this now. And the first thing that I like to do when I have all this information given to me is I like to look for these key endpoints in my intervals here. And I am going to actually take all that information and kind of pull it up above the graph so I can make some little notes to myself. So the first thing I have is between -2 and 2. So I know that I've got this -2 here and 2 here. So let me mark these lines in, 2 and -2. Then from -6 to -2, so I know something's going on here at -6. Let me try to mark that up here. Okay, so -6, -2, and then 2 and 6. So again, I'll want to pull this line up here for the 6. And then the next thing, -3 to 0. So at -3, I'll have this line here. And then 0. And then 3 to 6, so at 3. Okay, so I think those are all my endpoints of the intervals that I'm given there. So I'm putting this up here just so, like I said, I can make some notes to myself. Then if I look down at this third bullet, the end behavior, so it says the limit out to the positive infinity side of x is 3. So that tells me I'm going to have a horizontal asymptote at f of x equals 3. And then in the negative direction, the limit is 2. So I'm going to have a horizontal asymptote in the negative direction of positive 2. So I'll just put those in there for now to be like guidelines for helping me graph my function. All right, so the next thing I like to do is I like to look at the second derivative, believe it or not, because like in the last problem, I know that the second derivative tells me something about the shape of my function. Is my function concave up in that interval, or is my function concave down in that interval? So I am told here that the second derivative is positive when x is between -3 and 0. So from -3 to 0, my second derivative is positive. If my second derivative is positive, that means I am concave up. So I'm going to just draw this concave up symbol over here from -3 to 0. And from 3 to 6, my second derivative is positive there also. So again, I have this concave up shape from 3 to 6. Then the next line tells me that the second derivative is less than 0, meaning it's negative from negative 6 to 3. So that would give me the concave down shape there. And again, the second derivative is negative from 0 to 3. So again, I have the concave down shape here, excuse me, from 0 to 3. So that is helpful. Now the next thing I want to look at is, sorry, I'm just trying to clean this up a little bit. The next thing that I want to look at is the information that the first derivative is telling me. So let me change colors. All right, in the first place, I see that the first derivative is positive. Now, if the first derivative is positive, that tells me that my original function is increasing. And this tells me my original function is increasing then between -2 and 0 and +2. So it's my original function is increasing here and here also, right? Between -2 and 2, that whole interval here, my original function is increasing. Okay. My original function is going to be decreasing when the first derivative is negative. So here, the first derivative, f of x, is less than 0, meaning it's negative, when x is between -6 and 2. So in other words, my original function is decreasing, right, for this whole interval between -6 and 2. I have a decreasing function there. And then between 2 and 6, also, I have a decreasing function. All the way over. Sorry about that. I really needed that line to go all the way over to the 2, because between 2 and 6, I have a decreasing function. Okay? All right. So now, let me try to then see what's going to happen down here on my original graph then. So let me change colors so I can graph the function. And let's see. Looks like I will have an inflection point right here at x equals 3. I will have another inflection point at x equals 0 and another inflection point at x equals -3, because that is where the shape goes from being concave up to concave down. Okay, it also looks like I will have a maximum value, a local maximum at x equals 2. I'll have a local maximum there because that's where my original function goes from being an increasing function to being a decreasing function. I will also have over here where my function changes from being right here, my function is decreasing here and increasing there, which means that at x equals -2, I will have a local min. So let me put that in. I will have a local min at x equals -2. All right, now the one thing I don't know is exactly where this is going to sit on the graph as far as vertical. I could be higher than I'm going to draw this, could be lower than I'm going to draw this. It doesn't matter because we don't know anything about the constant value. But we do know that the shape of the graph is going to look like this. So let me go ahead and at 2, I'm going to put some maximum value. And at -2, I'm going to put some minimum value. And I know that when I cross, whoosh, that's pretty bad there. And then I know that between these max and mins, my shape is in this region concave up and in this region concave down. So I'll look sort of like that. Okay, I know that at x equals 3, I'm going to be changing my concavity. So I will look like this until I get there. And then I'm going to start to head off here, approaching that f of x equal 2 line. I know that when x equals 3, I'll be changing concavity again. So I've got to have this shape until I hit there, and then I'll have this shape, and then I will be heading off towards f of x equals 3. And so that is the general shape, and you can check to make sure that you have all the requirements. So between -6 and -3, is my function decreasing? Yes, it is. Between -3 and -2, my function is still decreasing, but yet now instead of decreasing with the concave down shape, it is decreasing with the concave up shape here, because I have my point of inflection right there at x equals -3. And then from -2 to 2, I am increasing the whole way. I'm increasing in the concave up fashion, and then I am increasing by less and less and less, giving me the concave down shape until I reach a peak at x equals 2, which then I start to go down, but still with this concave down shape until x equals 3. My concavity changes, and then I start to head off towards my horizontal asymptote in the other direction.